Hello viewers, you're welcome to another exciting moment here again. I am so happy to have you there watching, and today's live stream I want to talk about differentiation of polynomials. We're going to keep everything really simple and short, solving two examples, and that is all. So once we're done with that, that is all. So let us go into solving, or how to solve, or how to differentiate a polynomial function. Let us see what it is. Alright, let's go to the screen. Now the first thing I want to show you here is that we have y is equal to kx to the power n. Now x here is a variable and n is the power of x. This k here is a constant. It could be 1, it could be 2, it could be any real number, but it's different from x. So that means y is a function of x, okay? And because y is a function of x, I can actually differentiate y with respect to x. And how do we do that? Very simple. This is a polynomial, okay? So how do we differentiate a polynomial? It's just like this. Differentiating y with respect to x just only tells you that multiply this n with k, and that will give you nk, right? Whenever you multiply n to k, you get nk. And the next thing you do, you take away 1 from this power of x, and then you're left with n minus 1. And that's all. We've differentiated that function x to the power n. So let us see a real example and see how we can differentiate it. Now if I have y is equal to 2p squared plus 5p to the power 7. Alright, we are asked to differentiate this function. How can we differentiate this function? The first thing you want to look out for is y is a function of p. Y is expressed as p. So then we can differentiate y with respect to p. And how do we do that? Following the principles of polynomial differentiation. That is it. So I can differentiate y with respect to p. And what happens? These two can multiply these two here. So I've got 4. And the next thing, I'll take away 1 from the power of p. So I'll be left with just p to the 1, which is still p. And the next thing here, we have 7 multiplying 5. That will give me 35. And the next thing I'll do, I'll take away 1 from this power of p, and I will left with 6. So I have p to the 6th power. And this is a solution to that particular problem. We have just differentiated. Now let us take the last example and we call it a day. Now this example is this. If I have y is equal to 3x to the power minus 2 plus 5. Now we want to differentiate this function. Before we get started with this problem, I want you to have in mind that whenever we differentiate a constant, we always get 0. Whenever we differentiate a constant, we'll get 0. For this case, you can see that this guy is a constant. The relationship of x here is just to the power 0, so it's just a constant, right? That's it. So now you can see y is a function of x, so therefore I can differentiate y again with respect to x. And of course, even if we have a negative 2, it doesn't matter. We still multiply the negative 2 with 3, and we have a negative 6. And what do we do next? We take away 1 from this power here, and then we'll be having x to the negative 3, because minus 2 minus 1 is minus 3. And what did I talk about a constant? Whenever you differentiate a constant, it gives you 0. So our final answer will be minus 6x to the power minus 3. Thank you all for watching. I'm so happy to have you there still till this time. I want to see you in the next class, and until then, bye bye and God bless you.